Australia was hit by a devastating 180 metre or 590 foot high mega tsunami sometime around 5,000 years ago. The evidence left behind by this event is widespread and very obvious, and the scattered deposits left by it run across a staggering distance that sees damage from this event popping up in southwestern Tasmania and stretching all the way up to this point in Western Australia. This tidal wave of truly epic proportions was generated by a comet impact that struck into a deep section of the Indian Ocean over here, spawning a giant mega tsunami that barreled forth in all directions. This is episode 3 in the series where we document the visual evidence left behind in present day from this event. In episode 1, we kick this series off with a deep dive into the impact, where we discuss how to identify the features before going on to document the significant damage left behind by this event, upon which the entire city of Perth is built. Then in episode 2, we travelled from the bottommost point of Western Tasmania, up through the islands in the Bass Strait, before heading to Victoria and documenting the evidence that was left there, before ending just before we hit the border with South Australia. In this episode, we'll begin by covering the incredible damage present in South Australia as we slowly journey further west, documenting the destruction that was wrought and the depositions that were lain. And this slowly intensifies as we progress throughout the video, and as we go from South Australia through to Western Australia, where we'll then journey all the way up north, to finally discover what is by far the most spectacular evidence of this event that has been left behind in the very far north of Western Australia. On top of this, I'll also explain the difference between chevrons and the many aeolian deposits that we see all across Australia. And I'll also be outlining this video in a more evidence-heavy way, since I saw a few people were skeptical that these were chevrons to begin with. And this skepticism is definitely warranted and necessary. And in this situation, this skepticism came with some positivity, as the necessity to prove myself led to me attempting several solutions inside of the simulator to see if there was any way I could better show and illustrate the damage and chevrons that have been deposited all around Australia. And then I realised that by altering the time of day, the shadows cast by the sun at this angle lead to a highlighting of the chevrons. But not only that, by adding a snow function, I can further highlight the topography. And this has not only led to some incredibly stunning highlights of the chevrons, but it's also allowed me to track the wave damage much further than I originally did in my earlier assessments, now that I can better identify features on the land. So now, let's get into it. We kick off here at Cape Bridgewater, in the far western section of Victoria. These massive chevrons appear very clearly on Google Maps, and they stretch much further inland than the sand dunes suggest. A little west of Nelson is the beginning of the South Australian border, so let's cross over. In this part of South Australia, the high cliff faces and sheltering of this area has left little visible damage until we get to the point that was most impacted by the wave here, west of Port MacDonnell, around Shelley Beach. Massive directional chevrons smashed into this area and went many kilometres inland, depositing large sandy hills in the topographically low terrain. The largest chevrons begin after the visible sandy bits here, and they are quite massive, with them towering above the relatively flat land by 20 metres in some parts. At Canunda, we are treated to an exceptionally large and very long topographical low that displays the beginnings of the mega tsunami. These sandy hills are very impressive, but it's only when we dim the light that we can appreciate their bulbous topographical shadow. This really makes them pop. Notice how these shapes converge. Later on, we'll take a look at the difference between chevrons and aeolian shapes. And by aeolian, I mean wind-formed or wind-influenced deposits. A few comments stated confidently that these were aeolian deposits that I was covering. In this video, I will prove that to not be the case. And it begins by highlighting this joining that is the rule rather than the exception for chevrons. Keep this in mind, because it's important for later on. But it's not just the alteration of the sun that really makes this video different to the other two episodes. Oh no, it's the addition of the snow layer, because when we apply the snow layer, this happens. Look at the area behind the lake. We can now see the main extent and reach of the wave. The flattening of the land here by us humans might have led us to think the wave stopped before this massive lake here, but this is very obviously not the case. Another thing to note with chevrons versus aeolian deposits, as you will see here, is chevrons always have a point at which they stop, which is normally always abrupt. That point being the point when the wave loses its power, dumps its sediment load, and then begins to retreat. As we move on, there's an area that really caught my attention at Cowrie Beach, because of the very obvious horizontal lines that humans have excavated. It appears like they've flattened all the chevrons here because there's no agricultural land, and in between the excavator marks at places that weren't flattened, we see chevrons that were left behind. I can only assume this was an area that was prone to some pretty bad landslides, but if you live near here, or know or have a theory as to why we've done this, please let me know in the comments down below. Moving on now, and between Beachport and Robe appears very obvious and massive chevron deposits south of Lake St. Clair. This intense amount of wave damage and deposition stretches along this entire coastline, and is unbelievably vast. When this wave hit here, it would have been a truly cataclysmic scene to have witnessed. Now, from Kingston to Goolwa, we have the perfect situation to allow a mega tsunami to grow in height, as it ramped up and struck the shorelines of Long Bay. And strike it did, leaving a massive directional gash in the land from point to point, before suddenly stopping, as Kangaroo Island began to bear the brunt of the main wave as we approach Goolwa, further corroborating the fact that this is a mega tsunami, with areas being spared purely because of the direction these waves are travelling in. On Kangaroo Island, the evidence is clear. If this was an aeolian deposit, why is the locationing of these impacts perfectly in line with the impact centre in the Indian Ocean? And this will be very clear dozens of times in this video. At Porky Flat, obvious wave damage and chevrons occur. I mean, look at this, I can literally draw an outline of the main wave damage here. The waves went beyond this point, but this is the most significant outline, and it is an outline. This is a recent event after all. 5,000 years is a blink in geological time. These deposits become more intense at Seal Bay, where the damage is amplified as you can clearly see here. Breathtaking is one word to describe it. Holy f*** is another. The carving into the land is just unbelievable. Again, if this were aeolian, this is not how it'd look. The distribution, shape, and scattering is just not right. This is a chevron, and it's a chevron from the mega tsunami that was created during the Burckle crater impact event. Look at these perfect clear chevron shapes. They are flawless. As we reach the western coastlines of Kangaroo Island, we're greeted by some extremely large chevron shapes. After this mega tsunami scaled a 150 meter high cliff face to get here, where it then deposited chevrons up to around 20 meters high. It followed this river system deep into the land too. Now we get to an interesting part of the story. I originally thought Adelaide was spared from the mega tsunami. Sorry guys, unfortunately it was not. It's amazing to see actually, because the wave just managed to hit Adelaide in the southernmost section of it. This again corroborates the fact that these are chevron related deposits coming directly from the Indian Ocean Burckle crater epicenter, as this is literally just a small strip where the mega tsunami managed to navigate through Kangaroo Island to hit Adelaide, and hit it did. This is actually quite amazing to see. It wasn't so obvious until I altered the lighting and added the snow effect, and it's clear these two have been a game changer in reading the land and the deposits left behind by this event in a very clear and concise manner. It appears like this may be a sand quarry working on the chevron, and the clear cutoff points are here, with the tsunami barely making it through to hit this part of Adelaide. The land that sheltered the rest of Adelaide and bore the main brunt of the rest of the wave is here, and well, take it, it did. As you can see, this mega tsunami absolutely decimated its way through this island, inundating much of it, and leaving these massive visual reminders of the event. Now after this, near Port Victoria, we have some cheeky chevrons that have managed to make it through to strike here, leaving a large imprint of the event behind, which when compared to the surrounding land, bears a striking difference. Now here is a good chance to discuss aeolian deposits. These thin strips here, all of which are directional based on the prevailing wind current here, were formed by wind and are wind shaped and or formed. Unlike chevrons, the prevailing theme are horizontal lines that do not join. And when deposits like this do appear to join, they are always the exception rather than the rule. meaning the most predominant shape you will find aeolian deposits in are these kind of strip-like lines, unlike chevrons, which are, as the name suggests, chevron-shaped. Thistle Island is where we journey to next, and damn, check out this intense directional damage. Heavy chevron deposits occur in the northern part of the island. Now, this is another time to prove it moment. This is the clear direction the wave was travelling when it hit here, based on the chevrons. This means between this area, there should have been the tiniest, and I mean tiniest section of mega tsunami that made it through to hit the mainland. That would mean Port Victoria isn't the endpoint. But where is? Well, right here. A tiny area north of Port Victoria, where chevrons exist amongst an abundant aeolian-fueled background. After this, we move to Lincoln National Park, an area where the bay was enveloped and covered over by large sediment dumps. But that was nothing compared to the area you're probably staring at because it's sticking out like a sore thumb. This region in the west, which has the largest chevrons I've seen in South Australia thus far, with the most wave damage occurring in one location in my opinion. Coffin Bay has some of the most clear and distinct chevrons, and it's even more compelling when it's viewed under low light and with a snow cover applied. The shapes couldn't be more perfect, or more telling. These deposits are screaming mega tsunami in every possible way. As we leave Coffin Bay, we are greeted with the multiple other bays that were impacted as we journey westward evermore, with obvious alterations to the land that you should be an expert at detecting by now, especially if you watched all 3 episodes. The last piece of major wave-related damage occurs here, but let's not stop there, because what's hidden is so much more interesting than what is visible, as you can see. And this is the end of South Australia. We now cross over the border into Western Australia and head past Eucla, the first area where the wave-related damage begins, over here. It looks like barely anything happened here, but again, what's more interesting isn't what's visible. As you can clearly see, it was still submerged beneath a watery chaos in an instant, and chevron deposition did still occur, just to a lesser scale, with smaller and more numerous chevrons evident. Here, massive chevron deposits exist. The vegetation was plunged not only beneath a vast amount of salt water in a split second when this wave hit, but it was also surrounded by sand, and choked and buried alive by it entirely in some parts, as entire forests became covered over. As we look west, notice the very obvious directional wave damage. Every topographical low here has suffered the same fate. A vast burial by sediment, with large chevrons working their way inland, before finally tapering out at a similar point inland all along the coastlines here. Here at Albany, the giant wave was so high it actually flew over this cliff face over here, which has a topographical high of around 170 meters or 557 feet at the cliff face, where it then deposited huge chevrons here, before largely stopping at the bay's exit, with some finer sediment flows moving ahead of here. But at this point here, at Torndirrup National Park, there was a slightly lower topographical point of around 110 to 130 meters, which allowed a larger proportion of the wave and the sediment it was carrying through, where it then moved over these 2 islands, with the finer sediment from it being deposited when it made landfall here. How incredible would that have been to witness if you're in a plane flying over here when this wave struck? I mean, like, minus the damage and chaos and all that fun, boring stuff. After Albany, vegetation growth becomes more intense. This part of Western Australia is very lush, but even a perfect climate that is conducive to plant growth can't hide the scars of this event, with a large section of the island still so damaged from the wave impact that vegetation still hasn't recovered here yet. Massive bulbous chevrons dot this land, and it was actually this region here that took the main impact that otherwise would have struck the area of Albany much harder than it did, sparing it from the quite scary fate that occurred to this section of Western Australia. These chevrons are between 30 and 70 meters in size, or 98 to 230 feet. The cliff faces here bear some tremendous looking erosive damage from this impact, with chevrons dotted far inland from this point. Now get ready for it guys, because behind these cliff faces are the massive chevron hills that were deposited by this mega tsunami in the background. Truly spectacular. Northwest of here, we have a similar level of damage, but some pretty large chevrons exist here in the higher areas, and we have these more smaller chevron shapes in the lower lying areas. From the northwest to the southeast, we have a varying level of topography, from flat land that is 10 or so meters high, before the terrain abruptly rises to a height of between 70 to 90 meters, where it then abruptly rises again here to a height of between 110 to 130 meters. I point this out because it's cool to note the differences in chevron deposition. The most impressive chevrons appear in the highest point, and as we get lower, it appears to get smaller and more numerous, which surprised me. I just thought it was cool to point that out. Unfortunately, much of the land surrounding the town of Denmark has been altered, so the slide that once existed in the topographical low here has been removed. But I imagine it would have been similar to these kinds of slides that we see occurring time and time again in topographical lows all around Australia. Skipping ahead now to the western shorelines past Walpole, we have this major tsunami deposit that has altered the land very dramatically near the area known as Burckle. This would have been a lush green forest before this wave struck, and now it's an obvious and ugly scar jutting out upon the still wounded land. Check out those massive chevron hills in the background. They are very dramatic and prominent. A little northwest of here, and we have these beautiful chevron formations. Again, note the direction that they are pointing towards. As we begin to move north up the coastline of Western Australia, the direction will change from what it currently is, which is a relatively west to east path at this point, to a direction that points towards the northeast. This can serve as a point of confusion for anyone viewing these structures on Google Maps or Google Earth, as the aeolian processes that occur in the middle of Western Australia create vertical facing lines, and the chevrons are also somewhat vertical facing as we continue to go north past Perth. I'll point out the differences as we go, but the reason this has occurred is because the Earth is spherical, so we have to take that into account. But before we begin to press on, it's worth noting just how far the chevrons here surged inland. Look at this, it's incredible to see. This entire area was absolutely blasted by this impact, with the wave taking advantage of some substantial topographical lows of under 20 meters existing here, allowing the tsunami to stream inland with ease. Unfortunately, agricultural clearing and levelling has hidden much of the evidence of this event in the western parts of it, but obviously enough exists to tell us that this was, without a doubt, one heck of a chaotic event, and yet I can't help but wish that I witnessed it. Strange. As we move on, we have massive visible directional sand sediments deposited southwest of Northcliffe, and the impact damage clearly stretches from here towards Augusta. It appears that where we can see these large sandy sediment deposits, we have lower lying land, and we can expect to see chevrons further inland than normal. This appears to be the trend I'm seeing. They hint to topographical lows. After this point, we have this region here, which is more or less a cliff face from side to side, aside from a few areas where rivers flow out to the sea. This area ranges from 70 meters or 229 feet, all the way up to 190 meters or 623 feet at its highest point. We can see clear chevrons on the topographical highs here, with these ones existing on the highest elevation. When altered, we can see the chevrons that ascended these cliff faces on all points. These massive sandy deposits indicate a topographical low point, where the land begins at 10 meters high, before slowly rising up 160 or so meters. To the left are more fainter chevron deposits that have been cut through by a meandering river that actually began its inception into life after this event and after these chevrons were deposited, and many stranded waterways exist on the topographical high points in the area just after these chevrons end. And this has occurred because this has dammed and isolated the former drainage networks, cutting off and stranding the pre-existing waterways. In the far north, bulbous chevron hills exist, predominantly in the more northerly parts. Moving on, and just south of Perth, we see the area where this wave damage recommenced. So you can see the directional aspect to this wave very clear, and I've pointed it out numerous times in this video. It begins here, moves up to Perth, and intensifies as we head north. We covered Perth in episode 1, so I'll just give you a cheeky glimpse into the chevrons here under the new lighting and snow display. This shot is located south of Perth CBD, around a Jandakot area. Here's one more taken in the middle to northern part of Perth CBD. Moving north to Gilderton, we're met with another somewhat clear low point. Chevrons stretch inland, and the town itself is basically built inside of these chevrons. The Gilderton sand dune tourist attraction are actually just these chevrons. Now, I'm not going to lie guys, I've traced chevrons that are very far inland, and I suspect this is from a past event that was, scarily enough, much more intense than this one. I don't care what anyone says, these are not of an Aeolian origin, in my opinion. I see small and large chevrons the same as I would with the Burckle crater impact around the shorelines, only these are 500 kilometers inland, which is 310 miles. This definitely warrants further study. As for this event, I'd be pretty confident in assuming it went 50 to 100 kilometers or more inland here, and in some places honestly it looks like it went double that. But it's hard to tell, because if there is another impact event that occurred relatively recently, that surged 500 kilometers inland, well yeah, reading this is pretty confusing. The recent, more obvious and larger chevrons here definitely point to the recent event stretching for that distance, but it was definitely not strong enough to produce chevrons that could surge 500 kilometers inland. It was nowhere near strong enough for that. And one can only wonder what horrible event occurred here at one point in time that spawned a wave many kilometers high with the capacity to deposit chevrons so deep inside of Australia. I stopped at 500 kilometers, it kept going. So honestly, instead of just disregarding this, someone really should get out there and take a sample of it, and that's probably going to be me, because I'm genuinely curious as hell to figure out what the fuck happened here. Moving past Gilderton, and we have one of the largest tsunami chevron deposits that I've seen thus far in Australia. Beginning after Brenton Bay and peaking at Wedge, these deposits are both tremendous and terrifying to see. The chevrons themselves are about 70 to 80 meters high. They inundated and altered this once flat landscape in a near instant. This incredible deposition stretches past this point, all the way up to and past Grey. It's amazing to witness these deposits in Western Australia because of how arid it is here, and how obvious these shapes are as a result. Soon we will take a look at the Aeolian processes, and how they both differ and interact with the chevrons that were deposited by this event. But what you are seeing are pure chevron deposits right now. Look at how far inland these guys go, and it continues beyond this point too, as is clear by the chevron-like shapes on the horizon. Now at this point, we are here. The aridity of the surrounding area will steadily increase from this point on, and the shape of the chevrons here is starting to become increasingly pronounced as a result. Check out how long some of these are. They just streak through the entire landscape, dwarfing it with their appearance. It isn't just long chevrons though. Just a little north of here, hundreds of smaller ones dot the landscape. We're at Lehman now, and this is where things begin to steadily dial up to max intensity. A large section of the land has been flattened out and built upon, which only serves to further highlight the dramatic difference between the giant deposits on the left to the smaller but more numerous ones on the right, as the wave began to push further inland. Very large and impressive chevrons exist beyond this point, the largest that exist in Australia in my opinion. The overall length of some of them is astonishing. The wave was able to just flow over this ancient, highly eroded flat land. Check this out, it's nothing more than chevron mountains. The sand from the event poking so evidently through, revealing itself in multiple chevron hillsides all over the place here. We have yet another two strips leveled by humans, allowing us to once again see just how incredibly hilly this land once was before this excavation was undertaken. At Kalbarri, the river system provided an excellent point of entry for this mega tsunami, which it readily took. The very pronounced chevron shapes show that clearly. To the west, the cliff face rises, and we see duller chevron shapes here as a result. The cliff face here was heavily eroded from this event, and this erosive damage is very pronounced for several kilometers. Check out this awesome chevron slide here. Yet another topographical low that the sediment slid into after scaling a cliff face and suddenly entering a flat terrain where the sediment just spread out in this beautiful fan-like shape. And finally, we are approaching the end of our journey. This is, in my opinion, the most visibly affected and damaged area in all of Australia. The coastline of Tamala up to Dirk Hartog Island. And you can see why I say that. I mean, look at this chaotic hellhole of an area. It's absolutely torn to shreds by erosive forces in some areas, and suffocated by massive chevron deposits in others. The cliff face is so straight too, because of how much it got smashed and pretty much instantly eroded when this mega tsunami hit. It's just the climax of this event in chevron form over here. These cliff faces are around 138 meters at their peak, with elevation slowly declining as we move north. And here we have many chevrons within a giant chevron. Very cool stuff. They are baby chevron. Now we have something very different and very cool. Check this out. What you are looking at here are massive chevrons. Duh. But inside the chevrons are sediments altered by aeolian action. The winds here have worn down the inside parts of these chevrons, and this has occurred as a result of their geographical location, with the westerlies hitting here hard. Aeolian action is the more straight lines, and the chevrons are the lines that meet. This is a perfect example of the difference between the two. There are many aeolian shapes that can be formed, but chevrons always look different in my experience purely because of the fact that chevrons are directional. They constantly shift their direction based on where they strike due to the fact they are originating from an epicenter and spreading outward. Aeolian processes do not do this. They trend with the direction of the prevailing winds. Eventually, in many thousands of years, these chevrons will be completely worn down, and these aeolian processes will take over as the dominant feature on the land once more. As we move further north, we begin to exit the area where the wave would have struck. These islands bear clear directional scarring in the bedrock here, and as we progress further north, the chevrons continue, leaving behind very large and distinct shapes. Notice how the direction of these chevrons has changed during the course of the episodes. The angle that it hit Tasmania at differs greatly from the rather upturned angle that it is now hitting this part of Western Australia at, and that is why this confuses so many people, and is why they rightfully mistake these chevrons for aeolian deposits. Many, including myself at the beginning, fail to take into account the curvature of the Earth when tracking the pathway of the mega tsunami. This is the area around the Cape Range National Park, and we have some really unique and awesome things going on here. Firstly, the video doesn't do it justice, but the chevron deposits at the bottom of the screen are actually at a topographical low, compared to the aeolian looking ones to the north of it. What we are actually seeing here are the almost completely eroded remains of chevrons from this mega tsunami event. The erosion was by aeolian processes clearly, and the reason this happened is because this entire middle section is at a dramatic topographical high point compared to the surrounding areas. So it has just been slammed by the prevailing winds here for 5,000 years since it was deposited. There are still some clear chevron shapes, but in a few hundred to thousand years these will be completely gone, and eventually the other, more preserved looking chevrons will follow its path and erode too. As we leave this area, we can see how this wave rode up a topographical low point, depositing numerous small chevrons, whereas the section of the wave that impacted the cliff face here had a much different pattern of damage associated with it, and the chevron deposits were more scattered, random, and different in their appearance, with them being more messy compared to the needle deposited chevrons in a lower land. So as you can see, the chevron deposition here is much more dramatic and obvious compared to the lusher parts of Australia. And after this point, the damage suddenly ends. We see nothing else. Aeolian processes take over, and that's what we're going to look at right now. What better way to end this than by showing you guys what an unaffected area of Western Australia looks like, where the prevailing modification placed upon the land is predominantly wind-blown. Here's one presentation of it. Notice how they are straight, and if they connect, it's the exception rather than the rule. Their appearance is drastically different to the chevrons we've covered in this series. These ones are curved, yet they look nothing like chevrons. And well, yeah, these are very obviously different. And now you've seen firsthand the effects that this event left over when it hit Australia. We've gone from Tasmania to Victoria to South Australia and all the way up to Western Australia in excruciating detail, documenting pretty much every noteworthy bit of land along the way. I hope you've enjoyed this journey. I've certainly learned a lot. If you have any idea where those chevron-like shapes that appeared over 500 kilometers inland from Western Australia came from, please let me know. Any possible impact events would be much appreciated. In the next episode, we're going to look at the chevron deposits that I found in Indonesia. Now, correct me if I'm wrong, but I think I might actually be the first person to have found and correlated these deposits with this impact event. If not, then all good, but I found significant evidence and I can't wait to share it with you guys. The next episode is going to be presented in a much more hurried state compared to the Australian series, and we're only going to cover the most prominent and noteworthy sections of the land purely because of the distance we are covering, as I intend on going from Indonesia, west past India, then south down Africa, covering Somalia, Madagascar, and ending our journey in South Africa.